Okay, we'll start with a few words about me. Jose, really nice to meet you all. I'm Colombia, but I have been living in Italy for 10 years now, so has been a while. I'm a senior software engineer at Microsoft, and I joined Microsoft through the Kinfold acquisition. Maybe you know Kinfold because it was a German company. And very quick, the agenda. I will have to do a very quick intro because I think it is necessary to create a context for this talk. Then I will go to the debugging container, the challenges we have identified, and our journey through trying to overcome these challenges, difficulties. I will show you, I will tell you what was the first thing we tried to do, what is the current situation, and what is what we are going to do in the future, what is the idea. Quick intro. Do you have ever heard about eBPF? How many of you? Yeah. Okay. The intro will be very quick, and it will be focused on observability, let's say. So from an observability point of view, the debugging point of view, eBPF, you can think it like you have an issue. So you have to look in the scope of that issue at a specific point when you want to introduce a piece of code. And that point, you want to collect as much information as possible to try to identify who triggered the issue or to get information around what is going on in general to identify the issue or to identify a possible critical situation, or if you are just observing just to show the user what is going on in the system in that scope. That point is called hook point, and once you collect all this information, you will share this information with the user space using maps. So it will, every time that the event happens, your code will be executed. You will put the information you collected into the map. And then in the user space, there will be another application that will be reading asynchronously the information from that map. Then the user space, it is up to you what you want to do. Of course, you can do a post-processing information or just show the information you get, or maybe try to identify with the information you collected what was exactly the issue. And why eBPF? I think everybody there have been a couple of talks already about eBPF. I will just say a couple of words that for performance, it is JIT compiled. It means that it will just-in-time compilation. Your code will be compiled into instruction sets that are optimized for the machine where it will be running. So it is the most optimal situation you have for running your software. Then from the security point of view, it will be, once you loaded the program, it will be only allowed for privileged users to modify what you loaded into the kernel. And before loading into the kernel, there will be a process of verifying the code to be sure that there will be any crash. There will not be any crash in the system, because of course a crash in your program that is running in the kernel will be a crash of the whole system. So after you will pass through a verification before loading the program actually. And in terms of flexibility, as I explained for the observability point of view, eBPF is allowing you to add, to modify or add more features to the kernel. So you are the normal process of the kernel, you are introducing a couple of instructions there to try to extract information and identify possible issues or just observing. I need to a little bit introduce BCC. BCC is a set of tools. It is the best place to start when you are beginning with eBPF. So there is a couple of tools already ready. It's easy to follow, easy to run. And it is the first and more active project for eBPF tooling that I have seen so far. And now let's go to the challenges we have found with that introduction, after that introduction. Well, I think it is pretty much obvious when we come to Kubernetes and containerized environment, the main issue is that the tools that we were using, the Linux standard tool that we were using, like TOP, TCP/DAM, SS to see the sockets, everything was aimed to be work on a process Linux context. So you are just trying to follow processes to understand what is going on with the processes, but is not aware about containers or even Kubernetes. So that's for sure the first issue. Let me show you just a couple of examples, like, for example, SXNoob is one of the most popular tools for BCC. It will be executed. It is a BPF tool that will be executed. The exec system call is executed in the system. So if I just simply run sudo exec-noob, it will show me every time there is the exec system call is being executed. So if I run ls, I will have my ls here. But the same if I run a Docker container, and Docker run, and I will run ls. Oops, sorry. Also here I will have also the execution there in the tool. The problem with this is that as you can see, you have all the processes in the host being shown there. Even if it is coming from a container, a standalone container, or if it is a Kubernetes container, or if it's any process running in the host, you will have everything together. So there is no way to identify if it is coming from a container or a Linux process. And for instance, let me show you. This is something I'd used a lot before in my previous job, just to see the sockets that were running in the system. If I run, it is not really. Let me like this. If I run it like this, let's make an example with Nginx. Okay. So if I run to see the sockets in the host, I will only see, of course, I will only see the one that is being ported in the host, because the sockets, when you run SS, it will run in the network namespace of the shell when you are running the SS. And every container will be running in a different, not every container, every pod will be running in a different network namespace. So in order to see the sockets that are being, available sockets inside the Docker, you will need to run SS into the correct network namespace. So for instance, I will take the pid and I will use ns-enter. I will use ns-enter to execute the same code, SS, the same tool, just inside the network namespace of that pid. And here we can see the Nginx that is listening at port 80. But this is something that you need to do manually. And the main point is that you need to know how containers are built with Linux namespaces to understand that every container is running a different namespace. And that's something that when you are debugging an issue, that you are focused on the issue you have. You don't want to understand how everything is built. You just want to see where the issue is. So just to summarize, what is missing here is the awareness of containers and Kubernetes. We have the list of all the processes, all the things that are happening in the system, but we don't know if it's happening in a Docker, in a pod, in a namespace, in a different node, anything of that information is available. And if I want to see only the information from my container and not everything in the system, it is not possible also there. And the other problem is, like, there are some tools that need to be contextualized. They need to be run in the correct scope. Like the networking stuff needs to be run in the correct network namespace to get the correct information. The same if I'm monitoring the packets, I need to run it in the correct network namespace. And if you are running Kubernetes, of course, also you have the problem of deploying these tools into all the nodes and maybe collect the information from all the nodes. If you want to see the information from a given Kubernetes namespace, you will need to collect all the information for all the nodes and put it together and try to do it manually, everything. So this was the starting situation for us back in 2019. And we decided to face this problem, this situation, using eBPF and focuses only on Kubernetes at that time. And the very first version of Inspektor Gadget was simply running on a script that ran the BCC tools inside the nodes. At least the deploying part was already solved. That's the very first version. But then we said, OK, let's try to do something better. Let's try to collaborate with the BCC project, BCC folks. And we added this support to filtering by containers. So when you execute exec snoop, you will be able to say, I just want to see what is happening in this specific container. We did it using the mount namespace, which is unique for each container. So that was a way, because inside the eBPF code, from the context, you are able to identify the mount namespace with some events happen. So you can correlate that mount namespace to the container and then show all the information of, OK, this is this container, and it's running in this pod, this namespace, etc. And this is, the very first picture I found from the version 0.10 alpha.1. The very, very, very first version, you can see it is executing a script. This script, Inspektor Gadget script, executing exec snoop. You can select the pods that it is considering using labels, and then you have to specify the node because it was running in one node. But in the output, you don't have the output of the whole node. You are all the output, the things that are being executed inside the pods that you selected using the label. Then the second step was to integrate it better with Kubernetes. The point was we need to combine to avoid just executing it in one single node and combine the output from all the nodes, executing it together and combine the output. We created a kubectl plugin called kubectl Gadget. And the part that was missing also is that you have PID information, what was the command that was executed, the parent PID, but you don't have in the output the information about Kubernetes, the Kubernetes metadata. So we enrich also that with the Kubernetes metadata. And of course, now we need to be able to filter by container, pod, and everything. So this is the output. The first example is the same as the first version. So you are selecting just for label, and you can see that it's collecting information from different nodes, and only for the pods that matches the label. The second one is filtering by a pod, specific pod, and the last one is just collecting everything for everywhere. All the namespaces, you can see it is collecting from different namespaces, different nodes, and it's collecting everything. So that was the second step. Now, at that point, we say, OK, we are making BCC aware of Kubernetes, BCC tools aware of Kubernetes. We have enriching the information. But there was some missing tools, some missing use cases in BCC. We tried to create some tools there. We start calling them gadgets. And there were also specific use cases for Kubernetes that were, of course, missing in BCC because it is aimed to work with Linux processes. And we come out with a very long list of gadgets. And some of them has been created by ourselves, and others have been just the adaptation of BCC tools into the Kubernetes environment. Nowadays, we have been submitted to the CNCF sandbox project. We are now, the whole process was already accepted. There is a very nice feature that I really like. It's the synchronization with the creation of the containers that we added. It means that you can start monitoring I don't know, the DNS exec, the exec. I like the exec because it's the simplest to understand. But the exec monitoring the exec system call. You start the gadget and then you run your pod. And we will synchronously identify that a new pod is about to be created. We start monitoring the mount namespace for that container, and then we will show the very first step, the very first operation that the pod is executing. So we will not miss any event that is happening at the startup of the container. That's something I really like that we introduced it. The communication is synchronous, so we are sure that we are start monitoring right before the creation of the container. Then we continue integrating it with Kubernetes. We go one step further. That was, for instance, we have the trace TCP gadget that is monitoring the TCP activity, the connect, the accept, and the close for the sockets. And we are not just showing the IP address of the IP address involved. We are associating those IP address. If it is a pod, we can show. This is not really. You trust me. It is a pod, the namespace, the name of the pod, and the port where it is communicating. And then if it is talking with a service, the namespace, the name of the service, or if it is outside, it is just an R, that is a raw IP, and it's directly the IP there. What else? Wait. At this point, we said, OK, we have reached this maturity of the project. We have solved the first the issues we identified at the beginning, but we start making ourselves a lot of questions. The feedback from people was, OK, questions about how to improve it, how we can extend it, and we start with a couple of things that I really like. They're just new, and the question was, why to limit it to Kubernetes? At the beginning, we decided to focus on Kubernetes and on eBPF, but now we have all the framework, everything. Why not to just to be able to follow, observe, and debug standalone containers? If I start my container, and like I did with Docker, I also want to be able to monitor those containers, not just Kubernetes containers. So we created IG. It was previously called Local Gadget. It is fully decoupled from Kubernetes. It is collecting all the information about namespace, pod, and name of the container from the runtimes, from the container runtimes. It is supports ContainerD, Docker, Cry, and Podman. And let me show you a quick example. So if I run this. So I'm able to, it is, let me put it bigger. Maybe I exaggerate. So we are able to see the containers that have been created with through Kubernetes, and also the container we just created for the previous example, the one we created with Docker. So you are able to see all the containers that are being run in your node, in your host in general, and you will have the information. Let me show you the information if I do something like this. OK, this is the last one. The one for Docker, you have the information about the container, the image, name. We will add in also the digest. It is ongoing. And for the Kubernetes information, you have nothing for this one. But if you go for another container that was created through Kubernetes, you have also the information. And that's the list that we keep updated. And that's the way when a given event will happen, we will be able to associate the event to all this information. So your event, the event for the two happened, this happened, and then we will put together the information about the container where it happens. So you will have the full view of where a given event happened. And if I run trace exec, OK. Now I don't have the list of what is going on the whole host, but not only the things that are happening inside containers. So if I run again, I will have everything here. This is a standalone container, so I don't have the Kubernetes information, but this will be the same for a Kubernetes container. OK. So at this point, we continue making questions. I was people in the Slack channel asking, OK, but if you arrive Kubernetes, now you are standalone containers, why to stop there? I mean, it will look like we have the full list. We just we're showing the information about Kubernetes, now adding standalone, and now adding processes and everything. So it's like looks like we are moving back. But actually, the difference is that we are showing again, we are able to show again everything, what is happening in the host, in the containers, and with the host in the containers. But this time, you will be able to see, if you add this flag, you will be able to see everything the same that was executing, that was showing a sexnoob, the BCC tool, but you will have the information about the container. If it is a Kubernetes container, you will have everything there. So yeah, we are showing everything. Again, let's say you have a lot of information there, but you have everything enriched with the context of Kubernetes or container, of the container. What else I can show you? That's fine. And at this point, the question was, okay, we have a large group of plenty of gadgets, very many options. We are covering a lot of use cases, but what if we allow it? We are not, of course, covering all the possible use cases. Very many people will come in and saying, okay, I have this use case, I have this issue that I would like to develop my own eBPF codes to identify it, but I need to make the whole process to create a PR, create a new gadget, the documentation and everything. So the question was, why to limit it to the use cases we have identified? Why not allow users to run their own eBPF code, but using the framework we already created? So enriching the information with the Kubernetes metadata, with the container metadata, runtime metadata, being able to filter, being able to to capture when the containers are created, use the whole framework, but using your own eBPF code. And I think you kind of understand where I'm going. So we come out with this idea about containerized gadgets. It is under development right now. We have a design document in the GitHub. All this discussion is public, also in Slack. And there are three main things that I want to highlight. The user experience, we all already know how to deal with containers. So let's continue doing things in the same way. We decided that the gadgets should be packages into OCI images. And the implementation, of course, if you just want to write your eBPF code and let Inspektor Gadget run everything else and show the information for you, you will need to follow a couple of guidance in the code to be able to allow Inspektor Gadget to identify how to treat your code and show it. It has been in collaboration with Bumblebee folks, and this is how it will look for building a new your own eBPF code. So you have the code for your eBPF code, you have definition, this definition is optional. It's where you added any fancy way you want to show the information, the columns, how to show the columns, which are the priority, what is bigger, and etc. But if you don't want to do that, you just write your code and let Inspektor Gadget to run it and show the information in the default way it has in the columns that I showed you before. Then you can tag it, push it, and show everything like we are used to do with containers. Then the second point, the main point is how to run it, okay? And the point here is we are the same way running it, but okay, now it's stopped. To run it, the added value will be that your eBPF code, your small couple of lines of code will be enriched and will be using the whole framework we have already created. So that's the main point here. You are just running the exact code that detect the situation you are looking for, and then you will have the context or everything else. You will be built, push, ship it, and then deploy it in a Kubernetes system, because course, we have also solved this problem about deploying it in a Kubernetes system. And so what is next? Our goal is to make Inspektor Gadget a uniquely complete tool for eBPF inspection. So the idea is that you are able, using the same tool, because right now what you do is like, I'm debugging processes, so I use these tools. I'm in Kubernetes, I use these other tools. The idea is you just have one tool, one framework, when you can run your own gadgets or the gadgets that are already maintained by the team, or actually by the community, not the team anymore, the whole community. And you will be able to use the same tools for debugging processes, containers, and Kubernetes. Systemd units also. There is a PR that is not yet merged, but we will be able also to show, okay, this process belongs to this systemd unit, and you will be able to filter just to have the information about a given systemd unit. And I think you got already my point, where we are going with Inspektor Gadget. The idea is to make Inspektor Gadget be, for eBPF programs, what Docker is for containers. So you will be able to build, run it, and use the framework we already developed to do the part, not the difficult part, but the part that is collecting and connecting everything to show you just exactly what you are looking for. And that's all. Thank you. Actually.
Cool. Yeah. Thanks, Jose.
Can I go back to the presentation? Just a second.
Could you switch back to the slides?
It's fine. I really like yesterday there was another talk to talk about eBPF chaos. And he presented an example showing how to generate chaos in the networking, dropping some packets, and he showed the example about dropping some packets in the host. So that's one of the questions in that talk was, okay, you show me how to do that, but how can I deploy such a thing in a Kubernetes environment? This will be the solution. That's the answer for that question. You have your eBPF code, but how you bring that to Kubernetes? That will be the answer. And I wanted to say also that this is just an overview of the whole history and where we are going, what is our idea. But tomorrow, in All Systems Go, there will be another conference showing the current status of the development. There will be actually the demo showing how to build a package and run the gadgets, your own eBPF code. So that's for completeness. I think that's all. Okay. Now we can move to the question. Sorry.
Cool. Okay, thanks, Jose. Round of applause for Jose again. We'll have to debug what happened over there after your talk. But great. We've got a few questions coming up. Just a note, the Slido tag has changed from yesterday. We've made it a little bit more presentable. It's CD 11-12, which are the days of the conference. So I'll start with, why would I need eBPF? That's a loaded question there.
Why do I need that? I mean, I think I answered that in the introduction. I mean, from my point of view, or at least from the observability point of view, I think it provides you a lot of flexibility. You are not just locked to what the current tools offers. Like there is a generic tools. I don't know. TCP dump is showing all the traffic you have. But with eBPF, you could create your own eBPF code that just monitor when there is a DNS connection, for the DNS request. For instance, we have a gadget that record the DNS request, then wait for the answer, calculate the latency. You can do very specific things with the specific use cases you have in your companies. So that's the flexibility. From my point of view, it will be the flexibility it provides. That's the reason why you will need eBPF.
Cool.
from my point of
Next question. Is eBPF not basically crashing the front door of your security? Why is it safe? I'm assuming by crashing the front door is because you're running it on the kernel.
Okay, this is the security part. Not a security expert for sure, but I will say that it's yourself that is deploying the code, that you need to be a privileged user to deploy the code. The verifier has passed. I don't know. It's actually when you are trying to load a eBPF program, sometimes you have some errors about the verifier. The verifier doesn't like what you are trying to load. Sometimes I don't know what is the reason, but it's because it's just trying to cache any possible crash in your code. So you need to modify the things and be sure that everything is clear and there will be no infinite loops, there will be no issues with that. And in the security point of view, I mean, it is your privilege to need to load it. You need to be privileged to modify it. So the problem is not eBPF, the problem is if someone is privileged to do these kind of actions. From my point of view, I don't know. That's my.
I think for people who are really interested in eBPF as well, the people from Isovalent obviously can give you a lot of detail there.
Yeah, absolutely. Okay.
Cool. Is the Inspektor Gadget a replacement for using the Docker or kubectl command?
A replacement for using? No, absolutely not. Docker is just for managing the container, the container images. We are trying to do the same, create the same mechanisms, but for eBPF programs. So it's not a competing with Docker and anything, just following the same approach because we are already used to it. So we don't want to create another way. We are just that people is already used to do things in a certain way. It's better to people to make it in the same way so that you can get more adoption from the community. And for kubectl command, no, it is just a plugin. No, it's not replacement.
Yeah, so you still need kubectl.
Exactly.
Cool. Do I need to install anything in my Kubernetes cluster to use Inspektor Gadget?
No.
Apart from
just
Inspektor Gadget itself?
Yeah, install Inspektor Gadget itself.
Yeah. Any substitute for looking at a container's file system? Can eBPF do ls?
Yep. There is a gadget we developed. It is called snapshot processes. It uses eBPF iterators to go through all the processes. File system. Wait. I was confusing. No, file system. Maybe the same, the eBPF iterators, I think, because the eBPF iterator you can quickly go through the file system. Yeah, I think the eBPF iterator will be the answer there.
Yeah, I think we can always.
We can always, of course, I can
have that discussion.
Later
and check online. I'll just go through a few more. Are you guys thinking about a Rancher plugin as well?
A Rancher plugin. That will be something interesting. We haven't had the discussion yet, but if there is someone from Rancher,
get involved. It's an open source project.
Absolutely. We can have that discussion. We are really open to that.
Will there be a way to debug Kubernetes containers without being cluster admin?
The problem is that to deploy eBPF tools, you need to have sysadmin capabilities. So that's already.
But I think once it's deployed, then you don't need.
Deployed, okay, of course, yeah.
Then you don't need a cluster admin to use the tool.
Yeah, actually, to just use the tool, you don't need to be cluster admin. Yeah. Just to use the tool.
Yeah. So the deployment process obviously does need cluster admin.
I'm not sure.
Got a few more. Just can Inspektor Gadget collide with other apps using eBPF like Cilium?
Cilium is doing completely different thing. CNI. There may be, but there are a lot of tools doing using eBPF, but each of them are focuses on different things, and security, if I'm not wrong, Tetragon security and networking, Falco also. I mean, that's not the... each project is like focused on a different thing. We are just trying to create this framework to make it generic enough to allow people to do what they need to do. That's our goal.
Yeah,
right
you
now.
can deploy multiple tools using eBPF. They won't clash with each other. I'll take the last one, and then we can stop. How do I start to learn? How do I start to learn to write eBPF? I heard a lot how cool it is, but no one has the ability to tell me how to learn the language.
From my point of view, the starting point is the BCC tools. That's the point. Of course, there is a eBPF.io official webpage where there is a lot of tutorials, but I really like the BCC tools repo because there are separate, isolated examples, very simple, easy to follow. Okay, most of them.
So you can use
that's
any.
A point.
Yeah,
that's
you can use any
point.
programming language. Well, any. You could program eBPF in Go, for example, or Rust.
The part that this goes to the kernel is just can be written in C and I think Rust recently, and the user space can be in Go. We use Go, but there are a lot of libraries that can handle the user space side. But in the kernel space, just in C and Rust.
Okay. Cool. There is one more question, but we are kind of running out of time, so I'll let you actually come and talk to Jose during the break. Thanks a lot. Another round of applause for Jose.
Thank you.